All right, it is 12:10, so we'll go ahead and get started. Okay, so today we are going to be talking about charging behavior, and then we're going to think about technology adoption and consumer preferences. Okay, so this is really kind of a, I think, natural follow-on to our last lecture where we looked at travel behavior. And we'll think about kind of a topic that I think is unique in the vehicular space, about refueling behavior. I mean, with gas cars, I think it's a lot more straightforward. But with electric vehicles, I think there's a lot more diversity to thinking it, to talk about. So with travel behavior, and charging behavior, when we were talking about the way that people actually use the vehicles, yeah, it's kind of interesting, right? So the times when people actually drive their cars and the times when they charge their vehicles are inversely correlated, right? Because you can't actually charge when your cars are moving. And so the more that your cars are moving, the less kind of time that you have to charge your cars, but actually the higher the demand on charging is. Fortunately, most people, the amount of travel time that they have in their vehicle is kind of disproportionately small compared to the potential time that you could be charging your car, right? So we talked about the average person drives maybe 30 miles a day. Think about how long that would take you, right? Maybe on the order of 30 minutes to an hour, whereas for the rest of the time, your car is kind of parked. And so when it comes to electric vehicles, of all of these times when your car is parked, when are you actually charging? So this is kind of a little sneak peek here. These are distributions over the course of a day of what home charging looks like across like a population of vehicles. So if this is like midnight at the bottom left, during the daytime, if you're using your car, right, obviously you're not charging at home. And then there's this kind of ramp up later on in the day as more and more people have their cars at home and start charging again. And that's maybe inversely related to, on the far right, this plot here is showing what the charging pattern looks like out in public. You can see there's kind of a larger peak in the middle of the day. So we'll talk more about that in a moment. Right, but so refueling a gas car, as I was alluding to, versus charging an electric vehicle is pretty different. With a gas car, I just drive until my tank is empty or almost empty, then I can refill at the gas station. With an electric vehicle, you could be charging on a multiple days per week, and then there could be multiple locations where you could potentially be charging, right? And so, maybe in the first day I'm charging at work, I go out to eat at a restaurant that has a charger there, I can top up a little bit, and then I charge when I get home. Maybe I don't charge much on the second day. Maybe I go to the Arc, and I just charge while I'm parked there, right? And so the diversity of kind of charging patterns for electric vehicles and the way that they refuel is very different from how we traditionally think about this for gas cars. So where and when should I charge? How often should I charge? And how much should I charge? I think these are the sort of key questions that let us understand kind of charging behavior, which is an important concept to understand how we supply those needs. And it's going to speak to what we need in the public infrastructure for charging compared to home charging. So it's been some 15, 16 years since electric vehicles have kind of first come out. And so we've been able to gather a lot of insights from data. Although I will say, one thing to note is that the way that people were charging, 2011, 2012 Nissan Leafs is going to be actually pretty different from the way, we might be charging more modern electric vehicles. So that's one thing to keep in mind is when you look at some of the data in this realm, the age really matters because the technology is evolving so rapidly. And not just on the vehicle side, right? We've talked about how charging speeds have increased a lot too, right? Whereas 8 to 9 years ago, from fast charging, 50 kilowatts might have been the norm, and maybe today it's more like 150 to 200 kilowatts. And that's going to affect this sort of behavior as well. Okay, this is kind of our foundational EV charging pyramid. And again, these numbers vary a little bit, but generally speaking, home charging, work charging, and public charging, everything is built off of this foundation that most of the charging happens at home, like 50 to 80%. I also included, remember, for reference, right, the relative cost of charging. So again, depending on where you live, home charging can be anywhere from 12 cents to 45 cents in California. It can actually even be higher than that, but most people aren't charging on peak. Work charging depends, again, where you're charging. That can be anywhere from totally free up to some base level tier of electricity. And then generally speaking, when you public charge, you pay a little bit of a premium for being able to charge faster. And so the electricity rates that we see in public are typically more expensive than if you were to be charging at home or at work. Okay. So this is kind of the basic division. Why are these numbers ranged in this way? Well, actually, it's not that you can totally separate all the charging into these buckets very cleanly, right? Because some people charge both at home and also at work, or at home and in public. So this is from a survey, I think from like 5 or 6 years ago. But the numbers haven't changed too much from then. This pie chart gives kind of a breakdown of, a more detailed breakdown of that pyramid from before. So if you look at the legend here, the biggest slice of the pie in blue is if you charge, for people who basically responded that they only charge at home. Yeah?
So you mentioned like at-home charging, that it might be like more, how do I say it, like more efficient for like the person that can just go to their house and charge.
Yep.
But then what's the amount that's reflected on like a PG&E bill if you're charging at home, or is it not accounted for?
As in, if I own an EV and I charged at home and then I looked at my PG&E bill, like how much of the bills from, okay, well that will depend kind of person to person. There isn't, so when you get your PG&E bill, there won't be a breakdown for your EV because PG&E doesn't actually know where the electricity goes to. You would need a separate meter. But let's see, an average, well, okay, I'm not gonna do this math in my head right now, but if you're driving like a typical person and you're using kind of the average electricity, I've heard that bills can double or even more. But that's all relative, right? And so if you were driving a gas car, generally speaking, it would be cheaper. And so your electricity bill shoots up, but your money that you spend on gasoline drops to nothing, right? Yeah. So anecdotally, double for an average, but I can be more precise about that. I'll do the math and get back to you. Yeah. Any other questions or comments? Yeah, okay, again, so this pie chart, again, is kind of just a more detailed breakdown of the pyramid from before. Blue, the lion's share, right, is people who only charge at home. Then you have some people who only charge at work. That was me for a long time because we had free charging at work, and so I would just take my car in and charge at work. But that would be, I would say, probably a relatively small portion of the population can actually rely on that. Even smaller proportion would be other only, so that's mainly like public charging. And so think about if you didn't have work charging and you didn't have home charging, you would only be charging, in public use infrastructure. The yellow is if you employ both home charging and work charging, and then this darker blue here is if you do home and public charging. And so you can kind of think of the combination of this 13%, this 16%, and this 53% as people who kind of regularly charge at home, right? And so you're talking about more on the order of something like 85% who are primarily using home charging to refuel, or at least using home charging to some extent to recharge their vehicle. Okay? Yeah, so again, high level takeaway, home charging kind of dominates. That generalization kind of breaks down depending on where you live and how you charge and the type of vehicle that you have. So this, for example, is just a slice where we've divided electric vehicle owners into pure battery versus plug-in hybrids, and then within those categories into people who live in single detached homes. And so this is what you would typically think of as your like suburban home, right? And then condominium, just people who own condos and apartments. And so single detached and condos may look somewhat similar, but apartments are going to look pretty different, right? And so people who charge exclusively at home, in a single detached house, that's 37%, versus in an apartment, only 12%, right? Whereas they use work 27% versus people who live in apartments primarily charge at work 45%. So if you live in a single detached house, you are 3 times more likely to charge at home compared to if you live in an apartment. So that living context really matters, and that can have to do with access, right? And so without the availability of charging, those who own electric vehicles have had to rely on things like charging at work more. But you can also imagine, as we'll see in a second, that the prevalence of people owning EVs in apartments is going to be pretty different from single family homes, right? They are probably going to be less likely to purchase an electric vehicle because of this limitation. Yeah, and so connected to this, right, is that accessibility piece. So how many homes can support charging? I think I've showed this slide before, but just to reiterate, right, if we look at different types of housing, so apartments or condos versus attached homes, which are, like townhomes, duplexes, triplexes, versus detached houses, which is kind of the stereotypical home that we're talking about, versus mobile homes. We can see, for our regular house, they have the highest availability of being able to use level 2 or level 1. And you can compare that, so some 60% according to this particular survey. There are other studies that have said this is actually substantially higher. But we say 60% have access to level 1 or level 2, whereas in an apartment or condo, only about 20% have access to level 1 or level 2. And especially level 2 is this orange slice here is a lot smaller. Okay. Any questions? So there's other work by the California Energy Commission. They put together this report a couple years ago which looked at access and support for home charging. And so again, this is a different way to essentially say the same thing, where they looked at differences between, in the blue, single-family homes versus in the red, multifamily homes. So single-family homes are typical houses. MFHs are multifamily housing, so that's like your apartments and condos and townhomes and that sort of thing. And so people with access to level 1 or existing access to level 2, and then potential access is like if you were able to get like an electrical upgrade and install that infrastructure, and then with parking behavior, if you're willing to like park on the street or access it in some other ways. And so generally speaking, again, the main takeaway is this blue bar is generally just higher than this red bar. So this idea that charging access at apartments and condos and multifamily housing in general is just a little bit more difficult and a little less accessible. Okay, any questions? I mentioned earlier that that at workplaces there sometimes you can get access to free charging, and surprise, surprise, right? People are more likely to charge at work if you have access to that. We actually have some data to quantify that effect, so I thought it'd be interesting to kind of just include that here. The way that you read this chart, it's a little complicated, but the idea is that each of these colors correspond to a particular cohort. So you can look at this blue, for example, as kind of our default if you had to pay for charging at work. If you own a full battery electric vehicle across the population, what does that breakdown look like? In a given day, 23% of those people don't charge, about half of them charge at home, about 15% of them charge at work, 6% charge in public, and then 9% charge at multiple locations. And see what happens. How does that change when you actually do have free charging? The people who don't charge maybe goes down a little bit, but the main thing is that people who charge at home drop from about 50% down to 20%, whereas they will switch to charge from 15% at home up to 15% at work up to 44% at work, right? And so basically, you make it free, that induces shifts in charging behavior, and we can kind of elicit sensitivity to prices based on data like this. Okay, so generally speaking, the amount of charging at home halves and the amount of charging at work doubles when you have free charging. Any questions? Okay, I thought this might be a good slide to have a quick discussion about, so maybe I'll give you guys a moment or two. We've been discussing this idea that like people who live in apartments or condos don't have access to home charging, right, or have much less access. So what do you guys think? What options, if you owned an EV, what would you do? How would you try to charge? What options might people prefer amongst the sort of potential options that you guys discuss? Okay, so take a quick minute and think about the possibilities here, and then we'll reconvene. Okay, let's reconvene. Okay, can you guys offer up some of the options that you guys were thinking? Just raise your hand and throw one out. Anyone? Yes. Okay. Yeah, so even at the apartment building, some places are actually providing access to charging and installing that. Okay, great. Any other ideas for charging locations? Is that the only one that you guys thought of? Yes.
If your work supports it, you can also charge at work.
Okay, workplace charging, as we've been discussing. Any other ideas or formats? One more. Yes. Okay, yeah, yeah. So identifying locations that are kind of convenient because people use them anyways. Yeah, yeah, that's great. So, yeah, in fact, there are, and I would say this is kind of a continuing area of evolution, especially as we think about, more and more people in apartments who are running into this issue of having access. Um, so there are lots of different ways that we could think about doing this. So on street parking, and so even if you don't have access to a garage or the garage itself doesn't provide charging, you could have on street parking that have chargers nearby. Of course, you could have kind of the gas station model that we see over here. There are these like little modular, battery swap stations people have talked about, right? This bottom middle one is kind of an interesting concept. It's very common in Europe, but less common in the US, more because of the way that our grid is built out. But in Europe, they don't have level 1 charging. Everything operates at a higher voltage than the 120 in the US. And so for them, basically the wall plugs are level 2. And so it's very common to have these poles that basically provide level 2 power, and then people bring their own cords to plug into it. And so their street parking, it's sort of default on level 2 at very low cost compared to like setting up a little charging station in the picture above. And then you could have things that even could be disconnected from the grid. So here's a little example. In a parking space, you have a modular set of solar panels with its own bank of battery storage. And so that doesn't need to be connected to the grid, and that can simplify on a lot of the costs and upgrade requirements that you would need. You wouldn't need to do all of that trenching. You don't have to work necessarily with the utility to connect everything. Has anyone ever seen one of these, on the bottom right? There is one of these in Davis, actually, in downtown. So if you're on First Street, by the theater, there's the parking lot across the street. There's a set of 2 or 3 chargers that's just powered by a solar panel and batteries, and so that one is actually disconnected. So if you're ever interested in seeing one of these, there's one right in downtown, right next to the movie theater. I will say that the solar ones tend to be a little bit more expensive and a little bit less efficient. If you drive, 35 miles a day, 4 miles a kilowatt hour efficiency. You're talking about 9-ish kilowatt hours of energy that you need. So the actual solar energy per square meter times that panel efficiency times the panel size times the hours of sunlight. This setup here might be able to provide kind of like 1 day's worth of charge every like 1.5 to 2 days. So it's not like this thing is going to be all that effective, but in some cases can be useful. Okay. Any questions? Okay. And then thinking about other places, where would people charge if they couldn't charge at home? So we asked this question to a much sort of broader audience, and this is kind of what they said. School is a possibility, although relatively less popular. Transport hubs. So thinking about if I live in the Bay Area and I wanted to use the BART, I could have something at like a BART station or at like a train depot. The Amtrak downtown. That might be an area where you would think about charging if you're commuting. Airports, gyms and sports facilities, and they're getting more and more popular, right? Entertainment venues, so this might be like a movie theater, at hospitals, and then kind of the most popular ones are like restaurants, public parking lots, shopping malls and centers, where we've actually seen a decent success, I would actually say, for infrastructure deployments. A lot of larger malls with large parking lots have installed these kind of over the years. And then kind of the highest popularity one is rest stops. So I will say that the use case of these things can also be pretty different. So consider this idea that you want to charge on a corridor versus local charging. We've kind of alluded to this in a couple discussions in this class so far, but this idea of like corridor versus occasional charging versus long trip charging, these all speak to the use of chargers in very different ways, right? And so if it's just a charger at a grocery store that I occasion like once a week, right? Maybe that's a more regular use where I can top up my vehicle versus a charger that's on the I-5 for when I drive down to SoCal for like Thanksgiving or Christmas, right? That longer trip charging, that use profile is different, and the use case is different. So just know that now these gas stations that have been able to kind of accommodate any sort of demand trip with charging infrastructure, I think the picture is very different, and you have to design the system to think about all the different use cases and use profiles, so you can do it in the most, let's say, efficient way possible, right? So long distance trips. In a given year, how many people drive over 200 miles? And so with people who own EVs, the number is around 2 when you actually use the EVs. But on average, for an EV owning household, they may actually do a total of 7 sort of trips longer than 200 miles. And when I say over 200 miles, that's kind of just the cutoff. The sort of average of what we call long distance trips is usually around 400 miles. And so what does that mean? That means that I'm a household that has a gas car and an electric vehicle. And for some of those trips, I might be using the EV. But for many of the trips, I'm just using the gas car. And so that shifts our picture of what the infrastructure is able to accommodate today. And maybe the charging needs to be more prevalent or faster in the future if you're thinking about the sort of shift where we want to go from 2 long distance trips a year in EVs all the way up to the 7 that people usually do. So when we think about the design of charging stations being placed for long distance trips, one of the ways we can think about sort of different attributes of that charger deployment is by asking people. This particular study, so this is something done by a colleague of mine, where they were interested in looking at attributes of long distance chargers. So here it's like the speed of the charger, how much it costs to charge, how long it takes to charge, how far it is from, let's say, the freeway. If I want to get off the freeway to go charge, how long am I willing to drive? How long the queue times are, which speaks to how many chargers that you put out on average, and then whether or not there's amenities nearby. These are all the sort of categories. We don't need to get into the specifics, but this is known as a conjoint experiment, where you elicit people's values for these things by asking this question a bunch of times to your survey respondents. Both within a survey, you might have to pick, my choice between A or B like 5 or 6 times, and then you have to ask a whole bunch of people this question. And in doing so, you are able to look at the trade-offs that people are willing to make. So, you guys could play this game right now, looking at this table, look at the attributes and think about which one you would prefer. Maybe we can ask the class real quick. So take a look at the differences between A and B, and raise your hand if you would prefer location A. Okay, a couple people. Raise your hand for location B. A lot more people. And so some people are valuing certain things a little bit differently. I would assume this one's a little bit more extreme. I'm assuming that the cost is probably the dominant factor here. And a lot of these, maybe in some cases, the detour or the waiting time plays kind of a bigger role, right? So we're eliciting essentially different preferences for these different attributes. So if you ask kind of a broader population a set of these questions, you end up figuring out what things that people kind of prefer versus things that they don't like, right? And so across the sort of population, where I'm not going to show the actual kind of numbers here, right? But people generally prefer faster charging, presence of restrooms. Actually, the kind of the biggest one from the experiments, from this particular experiment that was run, is amenities. So the presence of restaurants or cafes or that sort of thing. People are actually putting a lot more value into that than necessarily the speed. And then things that obviously have kind of some negative preferences, so cost, right? If it's more expensive, lower preference, charging speed and power, detour time, chance of waiting time. So from these things, we can actually kind of quantify the relative value of the different attributes this charging station could have. Okay, what about how much time and how much charge you actually use in a given session? One of the reasons why we were really interested in looking at this is that, especially in some of the energy models, a lot of people were just kind of assuming, oh, if I start charging my electric vehicle, I'm always going to charge the batteries to full. Um, and people would say, oh, and we'll actually just charge every day, kind of all the way to full, and that affects the way that the charging load distribution looks like. When we actually looked at real data, uh, this was actually pretty different, right? So, not a lot of electric vehicles were actually charging their batteries all the way to full. And especially in public charging events where maybe you're more time constrained, right? Maybe I'm charging at a grocery store. I'm not gonna just sit around, when I'm done shopping, I'm gonna just take the car and leave, right? And so charging, that assumption that you would sort of always charge your vehicle all the way up was not correct. This particular chart is a little bit older. This is back from like 2017, 2018. And this is a distribution of how much people were charging on 50 kilowatt chargers. And so actually the average is about 10, 11 kilowatt hours, which is substantially smaller than the full size of an electric vehicle battery. So it was very clear that on average, people aren't sort of fully charging their battery all the time. Yeah, there's this kind of interesting spike that you see here at 20 kilowatt hours. Actually, does anyone know why that happened? This would be a pretty niche type of feature. So this particular spike is because if you bought a Nissan Leaf back in the like 2015-ish time period, you get free charging at EVgo chargers for 30 minutes in a given session. And so this particular spike is people using that particular incentive where for a period of 2 years, you get this free charging, and so people would just go charge up for 30 minutes, and that would correspond very closely with this spike. Yeah, so a little bit more modern view of this, the amount of energy added. So it's log normally distributed, and the distribution looks different depending on kind of the ranges of your starting state of charge and actually on the size of the battery, right? These days, you have a lot more heterogeneity. There are lots of batteries of different sizes for different vehicles. And generally speaking, the amount of energy that you're adding will go down as your state of charge increases, which makes sense, right? So if I'm starting at like 80% already, there's just not that much more that I'm going to be able to add, right? And so on average, if someone's starting their charge at 80%, they might only be adding 5 to 10% into their state of charge, or 5 to 10 kilowatt hours. Whereas if I'm starting kind of empty, right, I might be adding more on the order of 35 kilowatt hours on average, but as high as charging all the way to full, right? So this is what kind of the distribution looks like across ranges of your SOC when you start charging. And so for those, just to clarify, this is like a box plot, right? And so the median is the orange line, and then your 75th and 25th percentiles in the box, and then your kind of full range by the whiskers. Okay. Any questions? So the other thing I wanted to talk about is the importance of charging access to actually impact our decisions. So going back to this idea that, certain groups of the population have more or less access to charging, and that can ultimately kind of even preclude the choice to adopt an electric vehicle. So the main thing here I want to point out, this is based on a survey of different things that influence someone's decision to purchase an electric vehicle. Here, this is like if you have an incentive, so CC4A, that's the Clean Cars for All incentive, and that can give thousands and thousands of dollars off on your vehicle. So if you have access to that, even in a reduced form, because it can be income based versus the full amount, right? So that can change your decision from like around 50% up to 55%. That is kind of just as influential as having access to charging at home, right? Or having these kind of destination and home charging availabilities. And so the idea here is access to charging is as influential to people as just like straight up giving them money to buy a car, right? And so we see that if you don't have access to home charging and you're only relying on public charging, that's like equivalent to a lot of the incentives that people are getting to purchase the vehicle in the first place. We also see that it kind of heavily influences a decision to not buy an electric vehicle after you've owned one. So this is a different study that a colleague of mine had done, where they were interested in understanding, okay, there's this population of people who buy electric vehicles, and actually when you go back to buy a new car, a small portion of that population actually decide not to get an EV the second go around. So this is known as EV discontinuance. So this is, again, a couple years old. I think the number is a little bit lower now. But 20% of EV buyers choose to discontinue EV ownership. And what is one of the main driving factors behind that? So when we look at access to charging, so workplace, I should clarify first. The top set of plots here, these are people who bought an electric vehicle and then continued with the electric vehicle when they bought a new car. And then the bottom graph is people who bought an electric vehicle and then chose to discontinue ownership once they got a new car. And so here, the workplace access is almost the same. And then public charging, there is some slight difference, but not a huge amount. The area that differs the most is for people who chose not to buy their vehicle, they had substantially lower access to home charging, right? And so only about 30% of that subset population of people who discontinued had access to level 2 charging at home, whereas 50% had access to level 2 charging at home and then decided to continue using an EV. So it's pretty clear from a couple of different angles that charging access is like one of the most influential pieces of whether or not you would purchase an electric vehicle. It's not that everyone who doesn't have access chooses not to buy an electric vehicle. And so one of the things that we were able to determine is also, empirically, what would drivers actually do without home charging? And so this gives some kind of perspective of that. use more transit, use Uber and Lyft more frequently. Very few people wanted to actually do that. But then replace BEVs with gas cars or plug-in hybrids or with hybrids, slightly higher prevalence relative to the other two options. But the highest ones are do more level 2 charging away from home, do more DC fast charging away from home. I would say the one that far and away has the largest substitute for home charging and willingness to substitute for home charging is charging at a Tesla supercharger. So, takeaway here is that most electric vehicle owners, they make do in certain ways, and the preference for that isn't very high. But for people who own Teslas, they deem that for whatever reason, right, the supercharger network is accessible enough that they don't mind replacing home charging with just charging at a supercharger. Okay? So the one exception to a lot of what I've been saying is for Teslas charging at superchargers instead of charging at home, or willingness to use superchargers to replace home charging. Okay, any questions? And then the correlation between charging and EV sales. We can see that in general, the number of locations and the number of plugs has gone up over time, kind of exponentially. And that is very much kind of tied to the sales of electric vehicles, as we've kind of discussed before. That's the whole chicken and egg. Do we need infrastructure first, or do we need chargers first? There are a lot of studies that have looked at these kind of moving together in correlation. But a lot of those studies, the one thing to note is that causality is a much harder thing to determine. And so I would kind of take that with a grain of salt, right? Not all relationships are causal. And so to say that one is leading to the other, that we need one first, I think is a much more difficult question. Just because they kind of line up and look the same doesn't mean that one causes the other. This is an example of that. Correlation doesn't equal causation. So the distance between Neptune and Earth correlates very highly with burglaries in Kansas, but likely they're not kind of causing each other. All right. Any other questions? Okay, the last topic that I'll talk about with charging behavior is that all of the stuff that I've been talking about has kind of evolved over time. We can look at the prevalence of charging stations and the relative ratio of like fast charging to slower charging versus home charging availability versus public charging availability. All of those influence overall charging behavior. And the way that we use our vehicles and their capabilities, right? And so this is an example comparing driving distance. As you drive more and more, one of the things that we found actually is that there's a corresponding change in charging behavior. So these are examples of different sort of different odometer readings in different regions. So North America versus Australia and New Zealand, where people will kind of use their vehicles slightly differently. And over time, the number of charges that people do per some amount of distance actually tends to go down, right? So we think this may have to do with this may have to do with comfort to charging. So maybe when you first buy an electric vehicle, it's a new technology for you. You want to like keep charging it as often as possible, keep it topped up. And then over time, as you drive the EV more and more, you become more comfortable with getting to kind of lower and lower SOCs without needing to charge again. And this is like a very clear picture of that. So here, when I first get the car, I want to keep the average SOC, starting SOC to be at 60% or higher, and that will drop. I'm more comfortable with having an emptier battery as I drive and become more familiar with the electric vehicle. And so even within an individual car and across the sort of population of vehicles, we see charging behavior changing in terms of frequency, how often you're charging it, that goes down, and then how much you're charging it and how fast you're charging it. All of these are kind of constantly evolving, both in the use and in the how people kind of respond to changes in technology, right? Because I also mentioned with like a smaller battery, you have to top it up a lot more, but with a bigger battery, that's less of a concern. Okay, so as a summary for charging behavior, home charging is used the most, and it's the most influential in terms of decisions for actually buying the electric vehicle. And then there's maybe a little bit more mixed evidence on whether public charging has that same level of influence. Public charging is important for long trips and occasional needs, and so that infrastructure is still required. And then preferences are different if you are doing routine versus long trip charging, right? So routine convenience, cost is more important, and on long trips, amenities tend to be more important, as well as the speed of charging. And then this question of what do people do if they don't have home charging, right? We kind of had that discussion about that, and that's still an area that is continuing to evolve. We do see lots of new solutions kind of popping up all the time in terms of replacing that home charging. But at the end of the day, it's not ideal because of how influential home charging is. You need a really good substitute for that in order to get people to invest in buying an electric vehicle. Okay, any last questions about charging behavior before we move on? All right. So our second half of the day, we're going to think about electric vehicle adoption. And so we've talked about kind of the market before, right? That was kind of in the second lecture. This is more thinking about adoption of technologies as a whole, and what goes into kind of the decision that ends up showing kind of the market that we saw, the market outcomes that we saw in lecture 2. So think about who actually wants to buy electric vehicles, and why do we actually care about learning about these types of people, right? So we want to understand what populations of drivers are buying electric vehicles and who isn't buying an electric vehicle. You can imagine that if we're on this trajectory to want to sell these vehicles, and automakers are interested in doing this, they might want to understand what it is about that population of non-buyers that they may need to address when they build, new versions of electric vehicles. We have to think about how many more people will buy EVs, as the range increases or as the infrastructure becomes more available. this lets us, set specific goals in terms of infrastructure development, in terms of like technology with the range increases, if we want to meet a particular target. And so what aspects of this should we target with policy, with technology improvements, infrastructure deployments, and so on. So there's this general concept known as the diffusion of innovation. And this is kind of a theoretical construct that thinks about how new technologies, so not just electric vehicles, but new technologies in general, kind of enter the market. So this thinks about how there is sort of innovation that's naturally happening with new technologies, and that's needed for successful adoption of that technology. It thinks about what actually contributes to innovations as they enter the market, and then who adopts new technologies. So this curve here is a generalization of the population of people who adopt new technology. So the first phase of people who purchase a new technology, so this is what's known as the early market phase. So consumers tend to adopt technologies at very different rates. And those characteristics lead to sort of this differentiation in adopters. And so the earliest people tend to accept or be willing to accept early market issues, right? And so this idea that, I might not have a lot of charging infrastructure if I'm buying an electric vehicle, or with like a cell phone, for example, maybe there's not very much, coverage with a new cell phone when it's first entering the market. So the earliest adopters, these innovators and early adopters, are people who are kind of more willing to put up with those kind of issues. They are often considered opinion leaders, and they're often kind of niche markets, right? So innovators are really going to be a much smaller segment of the populations. And then the actual speed of adoption depends on a number of factors, which we're going to talk about in just a moment. Following the early market phase, we have what's known as the mass market phase. This is roughly when you hit about 16% of adoption. That's where it becomes more of a social norm. You get more of these like word of mouth effects where enough people are kind of aware of it that you start hearing about it more broadly. And then a lot of those early market issues have been kind of worked out, right? So the product has been disseminated to a smaller population, and a lot of the kinks have been fixed. And this is generally when you're entering kind of that mass market phase. After this, a lot of the growth is essentially self-sustaining. We think of this as like the innovation has reached critical mass, essentially. So in terms of thinking about who adopts new technologies, very often there are specific attributes and characteristics of people that are doing that adoption. I guess this maybe comes as not too much of a surprise, right? But this is typically people who have higher education, higher income. They typically are younger on average. Gender-wise, more likely to be male, as well as having these, from an attitudinal perspective, being more favorable to change, more risk tolerant, right? And so some of those earlier issues with earlier technologies, right? You might be more willing to put up with that, and then favorable attitude towards science. And that's just kind of a general trend that folks have found for this sort of segment of the population. The 5 attributes that I was mentioning earlier, so this is relative advantage, compatibility, complexibility, trialability, and then observability, kind of in order from most important to least important. And things like policies can affect many of these things. And so later on in the class, we'll talk about more specific like EV policies and how they affect different parts of these attributes. And we'll note how that changes over time, right? So as policies maybe get phased out, are we at the right kind of place in the adoption curve that it makes sense to decrease the policies that might be pushing for these attributes to succeed? Okay, so to talk about what each of these 5 things break down to, so relative advantage, this is the degree to which an innovation is perceived as superior to its predecessor, right? So we think about an electric vehicle compared to a gas car. How does that play out in terms of the cost? How does that play out in terms of convenience, right? So cost-wise, the electric vehicles cost more than gas cars up front, but even today, over the lifetime of the vehicle, if we look at the TCO, right, they tend to be better. Convenience, this issue of taking a long time to charge and the range issues, those are typically the 2 main complaints with convenience. How does that compare relative to a gas car? Satisfaction, physical attributes. So satisfaction actually tends to be pretty high for electric vehicle owners. Physical attributes aren't going to be all that different from gas cars in terms of the look and feel of the vehicle. And then the social factors and prestige, and that one is going to be a little bit more mixed. It probably depends on who you're talking to. Compatibility, this is the degree to which innovation is perceived as consistent with beliefs, experience, and needs. And so you can think about what people think about electric vehicle versus a gas car. We can talk about the experience you might have driving and charging an electric vehicle compared to a gas car, and how that syncs up with your needs for travel, right? If you are driving a vehicle some amount of miles, if those needs can be easily fulfilled by your average electric vehicle, then the compatibility is high. Whereas if you are, driving 500 miles a day and you can't afford the time it takes to charge up, then the compatibility might be a little bit different. Complexity, the degree to which an innovation is perceived as difficult to understand and use. So ease of use, I think that not too different in terms of the driving part of it, get in the car, start it, drive away. Really, that part of it is not going to differ much from a gas car. I think where you might get a little bit more complexity is when you're doing the refueling. And so that plays into the ease of understanding the technology, relative advantage, and compatibility as well. So think about all the things that we've covered in this class so far. Are these, do these complexities trickle down into what you need to know as an electric vehicle owner? Probably not all of it, but some of it, especially with everything we've talked with the nuances of charging, right? And so certainly pieces of this are going to be more complex for EVs than gas cars, but a lot of it, especially the day-to-day use, is probably going to be pretty similar. Trialability, the degree to which an innovation can be experienced on a limited basis. Yeah, to what degree can I use it without adopting it first? So I want to test it out, right? And if you have to just cold make that decision of buying this, tens of thousands of dollar investment into a new technology vehicle, that might be a little bit harder to swallow. And so, can you go for a test drive? Can you use a neighbor's electric vehicle? Can you use, a ride and drive program to test some of these things out? That can help a lot. That can reduce the risks. So you might drive the car and think, oh, this is not so different from driving a gas car. Actually, I don't mind this at all. And that risk of making a large investment is mitigated. You could also discover some of the benefits, right? If you're driving around, oh, the acceleration is way better than I thought, right? And so trialability, the idea that you can test something out before you commit to it, can be an important factor. And then observability, the degree to which results of an innovation are visible to others. So you might think of this as like the neighborhood effect. If you see a bunch of these vehicles in your neighborhood, you're actually much more likely to want to adopt or be open to adopting the new technology. And so you see more of these vehicles or more of these chargers, you're more aware of it, and it's easier to visualize and or experience the benefits of owning that technology. Okay, so for electric vehicles, where are we in that pathway to broader adoption? So still early in the market for most regions. Yeah, so this particular chart I think is a little bit, actually no, it's been updated. Yeah, so this is updated to last year's numbers. One thing to keep in mind, this curve is about cumulative adoption, okay, and not new adoption vehicles. So actually, we have seen some prominent examples of adoption where they're actually looking at cumulative market share as opposed to annual. Or sorry, I'm getting this backwards. Using annual ones is incorrect. Using cumulative ones is correct. And so if we look at where we are cumulatively across the entire population, the figures are going to be really different. And so Norway, for example, on an annual basis is up near like 95+%. The US, for example, is going to be closer to 10%. But when we think across cumulative amounts, we're still definitely in the early adoption phase. And so we still have some ways to go before we can be sort of in the critical mass phase. There's probably still support needed on the policy side to get us to be kind of self-sufficient on the technology. We are growing really quickly, but it just takes time to replace vehicles on the road, right? Because not everyone is buying a car every year. So a lot of the issues are thinking about how early we are in the transition, how hard it is for consumers to imagine electric vehicles, all of these issues we were talking before about observability, trialability. It's also difficult for companies to balance out kind of satisfying the demand and making sure that they're still able to make a profit. Projecting these kind of curves is really difficult when we're still in the early market phase. Once you're kind of a little bit further along, it's a little easier to extrapolate based off of like prior evidence what the sort of saturation of the market is going to look like. but the projection of what this curve looks like based on 1 to 2% adoption, it's still too early. It's very difficult to do it well. Okay, any questions? So regionally speaking, that adoption curve can look really different as well. You could have a lot of spatial clustering due to things like the neighborhood effect that I was just mentioning. Word of mouth travels kind of at the local level. So in some neighborhoods, you might actually be at that mass market level. And so this particular map is a map of the sort of greater Los Angeles metro area. And you can see that the number of electric vehicles in a given sort of census tract varies quite a bit, right? On the order of like hundreds of times different. And so that, again, that sort of adoption curve that I'm talking about, if you zoom in particular areas, can look really, really different. So what are the challenges kind of at the early market stage? So these are any deficiencies affecting innovation, infrastructure, and the whole ecosystem around the technology. So for electric vehicles, right, a long time it's like model availability. So it's not just on the demand side, it can also be on the supply side. You could actually have a lot of people who want electric vehicles, but there's not a lot of EVs driving around because they're just not being sold by suppliers, right? The high cost, issues with range and charging time, these are all things we've talked about before. Infrastructure reliability and availability, the cost of charging in public. I was, again, kind of alluding to this competitiveness between gas cars and EVs. In public charging, if you're doing a lot of that, you might be paying pretty close to what gas prices are today. And so that affects the competitiveness piece. And then low awareness if there just aren't very many vehicles driving around on the roads. Okay. So applying diffusion of innovation theory. So is the technology that we're talking about perceived as an innovation? The 5 attributes of innovations that we were mentioning need to apply here, right? So relative advantage, compatibility, complexibility, trialability, and observability are all going to play a role into how well this kind of fits into our innovation theory, whether or not there's early market issues, how many people have adopted it. Yeah, so the sort of niche of the technology is going to fall into different categories for different people. But generally speaking, we do find most technologies fall into that diffusion of innovation theory curve. It's just a matter of, as time goes on, where are we going to land? Is that curve going to encompass most of the population or just some portion of the population? I think that remains to be seen. That's an open question to a lot of regulators, right? So in California, we had this goal of 100% zero emission vehicles by 2035 for new cars being sold. And I'll just say there's a lot of discussion from experts in the field about whether or not that's possible. And that all relates back to this idea of our innovation theory and of how much of the population ends up getting covered by it. Okay, so that's kind of on the theory side. On the empirical side, we can actually go in and look at what type of people are actually buying electric vehicles. So maybe this part will be more interesting for some folks, thinking about sort of demographics. We mentioned that, generally speaking, in that innovation curve, that the early market adopters tend to be more educated, wealthier, younger, and male. So how does that hold up to the sort of evidence when we look at actual buyers today? Okay, so this is a plot on the left of people who buy plug-in hybrids, gas cars, hybrid cars, and battery electric cars, what the average annual household income looks like. And so for gas cars, around 90K, for hybrids, a little bit higher. And then for plug-in hybrids and full battery electrics, quite a bit higher, right? So like 50+% higher. So probably there, we're correct, right? So we definitely observed that the people buying this technology tend to, on average, have substantially higher than average income. Okay, education piece. Green is high school diploma. Yellow is graduating with bachelor's, and then blue is graduate level, so master's, doctorate, or some kind of professional degree. So our baseline is gas cars here. So kind of the highest is college, and then you kind of have equal high school versus graduate degrees. So let's take a look at full battery electrics. The college tends to be about the same, but you have maybe a third of people who only have a high school diploma versus almost twice as many people having graduate degrees. And a similar type of trend for plug-in hybrids as well. So, higher educated as well. So 2 of our 4 kind of confirmed via empirical evidence. Gender. So roughly 50-50 split between females and males for traditional gas cars, whereas it's like 65% versus 65% male versus 30% female. And then maybe a little bit smaller of a gap for plug-in hybrids, closer to 55 or 55, 65, 55 to 60% males and about 40% females. So same thing here. We observed kind of confirmation with the general diffusion of innovation theory. Gender-wise, we tend to see males being a higher proportion of the early adopters. Okay, and lastly, age. So blue is gas cars, and then dark blue and green is electric vehicles. And here, actually, maybe a little bit different, right? We actually see, relatively speaking, for gas cars in our sort of regular blue, there tends to be higher proportions at the sort of younger ages, especially compared to plug-in hybrids, where a lot of that is happening in later years. For battery electrics, maybe it's a little bit closer, where you have a higher in the like 30 to 39, 40 to 49, 50 to 59, but much lower at kind of the younger in your 20s. So there maybe it's a little bit less clear. And that may also have to do, I think there are some caveats to this based on attributes of the technology. In this case, cars just are a little bit more expensive, so that may play a role in kind of the relative amounts that we're seeing across ages. But so maybe For full battery electric vehicles, the jury's out a little bit. But for plug-in hybrids, it appears to be kind of the inverse, where actually older folks are preferring those. Okay. Other demographics. Yeah, so home ownership. So much higher proportion of people owning compared to gas cars for both plug-in hybrids and battery electric vehicles versus renting. That lines up, right, with what we were talking about in terms of the relative difference for people buying EVs who are living in homes versus living in apartments and other like townhouses type of thing. So that lines up. Political affiliation for cars in general, it's probably a little bit more evenly split between Republicans, Independents, and Democrats, whereas with electric vehicles, higher for Democrats. Yeah, not sure why EVs in particular have become such a sort of political sort of divisive area or topic, but it appears so. Although, you know, political affiliation only tells part of the story. When we ask this question as it pertains to like climate change, that's kind of a much bigger sort of difference. I think folks have tried to isolate these and it ends up balancing a little bit more. And so the environment piece gets kind of inherently pulled in and linked to electric vehicles, and that might explain some of the differences in terms of like political affiliation and ownership. But all of these things, the last thing that I'll mention is that these demographics have changed over time, which is essentially what you want, right? So the idea is that, okay, you have richer, more educated, younger people, or maybe not the younger one, richer, more educated, and more males buying electric vehicles. And over time, those are starting to converge a little bit more and more towards kind of the average population, which is what we want, right? This means that that the general population, more folks from that population are starting to invest in this technology. And so really, if you look at some of these demographics over time, the trend has definitely been towards pointing, you know, lower and lower incomes. You know, the education piece is decreasing, the gender ratio is balancing. Yeah, so this is not kind of a static view, and indeed we would expect this to change over time, especially as adoption becomes more prevalent. Okay, so I do have two kind of smaller subsections for vehicle adoption, but actually I'm thinking we won't need to necessarily go over this directly in lecture. You guys can take a look at the slides, and instead we do have our midterm on Wednesday, and so I'll talk a little bit about that so that we have time if anyone has questions before the quiz for the day to address that. So I'll let you guys kind of look at the slides that I post online to cover this, and I'm happy to address any questions about, you know, the last, you know, 10, 15 slides. Yeah, next, after the midterm, if anyone has any questions. So the midterm is just going to be during our normal class hours. The content is going to cover everything through today. there's going to be a series of a couple of larger quantitative questions and then a bunch of kind of short answer questions. Yeah, so does anyone have any questions about any of the material or the midterm? Yeah. So it's going to be kind of half and half. So the first couple questions are going to be quantitative questions where you will do calculations that are going to be pretty much similar to questions that you guys have done on the homeworks. And then short answer questions just based off of any of the material that we've covered throughout the class. Yes?
Study, would you say it'd be best to mostly look over the homeworks or mostly look over the exercise?
It's going to be a mix. Yeah. I would say the homeworks are going to help you most with the like quantitative questions that are at the start of the midterm, and then the latter half is just going to cover any of the material that we've talked about. I would say that material is not going to be like super complicated or tricky. I think if you've been able to understand and digest the material, most of the short answer stuff should be, I think, fairly straightforward. Yeah. Any other questions? Yes. No practice exam. The practice exam would be kind of just closest to your homeworks. Yeah. Yes. Yes. Calculators are allowed, otherwise nothing else. It's not open note or anything. Yeah, no computers, no phones, just calculators. So make sure to bring your calculator, yeah. Oh, yeah, unit conversions, all that stuff, anything that you need, you will be provided. So you don't need to like memorize conversions or anything like that. You need to know how to do the conversions, but yeah, anything that you would need for the purposes of the midterm will be provided in terms of unit conversions. Yeah. Do you need? No, they're just going to be printed out, kind of like the quizzes. No, there's no, multiple choice. Any other questions? Okay, so what I'll do then is we can pass out the quizzes now. I know we'll probably end up a little bit early, but if people then have other follow-on questions just for me, you can come up and chat after you finish the quiz.